So this is 5.4a, and the name of this section is called complex fractions. Basically, a complex fraction is a fraction with other fractions as part of it. So a fraction over a fraction, basically. And when you have something like this main line here, the bigger line, the thicker line, which will be in the book, that's your division line. So really what that says is 1/2 divided by 2/3, which is 1/2 times 3/2. You just invert and multiply. And you multiply your numerators, you multiply your denominators, and you're good to go. All right, but a lot of these fractions that we're going to do are going to be a bit different because we're going to have we're going to have variables in various parts of this. So if you look at example 2, we have 1 over x plus 1 over y over 1 over x minus 1 over y. All right, so in order to simplify this, we first of all have to combine terms on the top and make this into one fraction, and terms on the bottom and make that into one fraction if we can. If we can't, we do what we can do. So anyway, in order to try to combine these two, we have to have common denominators. So we're just going to look above the line and then below the line, and we won't cross the line until we're done. So again, like so many of these other lessons, I do this differently than the book does, but that's okay. I think that the way I do it is a little bit simpler. So I look and see what I'm missing over here that I have here, and I'm missing a y. So I'm going to put a y here and a y here. And on the right, I'm missing an x, so I'm going to put an x there and an x there. So now what do I have? Y plus x over x, y. Then on the bottom, I look and see what I'm missing over here. I'm missing a y, and I'm missing an x over here. So I end up with y over xy. I'm just going to keep it alphabetical. X over xy, which, when I put these two together, I get x or y minus x over, I should have an xy there, over xy. Invert and multiply. And this cancels with this, and I'm left with y plus x over y minus x for an answer. Okay. All right, so example number 3, top of page 442. I'm going to simplify this first. So simplified, that's going to be x minus 2, and it's going to be over x plus 3, x minus 3, difference of 2 squares. That's going to be over x plus 2, x minus 2, over x plus 3. I like to keep it all in parentheses. Okay, so now what I'm going to do is I'm going to take this bottom part here, invert it, and multiply. Okay, so this bottom can go away, if I can find my eraser. And I'm going to cancel what I can. Cancel that with that, and that with that. And I'm left with nothing on the top, which is a 1, times x minus 3, x plus 2. And there, I've got that. All right, so move on to example 4. This one's a little bit different because we have 1 minus 4 over x squared. We don't have two fractions. And then we've got 1 minus 1 over x minus 6 over x squared. So following the same rule I did before, I'm going to make this a 1 over 1 and this a 1 over 1. So I've got two fractions on the top. All right, so what am I missing here that I have there? I've got an x squared is what I'm missing. So I'm going to put an x squared down there and an x squared up there. So my top then is going to be x squared minus 4 over x squared over, now I've got three terms here. So I need to look and say, okay, what am I missing here? I'm missing an x squared, okay? I am also missing an x, but by putting an x squared there, I have the x here. So what I do is I look for the highest exponent, and that ends up being what I'm missing there. So I'm missing an x squared there, and I'm missing an x squared on top. And when I look here, I'm missing an x squared. I've got one x, but I need two. So I'm going to put another one there and one there. So now what I have, that was a 1, but I was missing an x. Since I had 1, I needed 2. So I added a second one there, and I added just one of them up here because I multiplied. Here, I'm not missing anything. Nothing is appearing here that I don't already have, so that stays. So that gives me over x squared minus x minus 6 all over x squared. Okay, so let's go ahead and invert and multiply. So I'm going to turn that upside down and multiply. Okay, so this all goes away. Okay, so that being the case, I can start by just canceling this with this. This here reduces to x plus 2 and x minus 2, difference of two squares. And this is going to divide into two binomials. And those two binomials are going to be on the bottom, we've got x minus 3, x plus 2. 2 times negative 3 is negative 6, and negative 3 plus 2 is negative 1. Okay, so that's right. All right, so now I can cancel that, and my final answer is x minus 2 over x minus 3. All right, so we've got one more to do, and we will be done. This goes pretty quick. It's a pretty short lesson. 2 minus 3 over x plus 1/3. Oh, goodness sake. So we're going to combine these two by getting a common denominator. So I'm going to make this a fraction and look and see what I'm missing here that I have here, which in this case is a 3. So I'm going to have a 3 on top, 3 on bottom. Then I'm going to look and say, what am I missing here? Nothing. So that's going to stay the same. So let's rewrite this as 2 minus 3 over 3x plus 1 over 3. So let's just look at simplifying this. We'll stick the 2 on there later. So this is actually 2 minus 3 over 1. And I'm going to invert and multiply. Okay, so now I'm going to combine these here. Okay, now we've got a little bit of a mess here because I've got this doggone 2. So what I'm going to do is I am going to put a 1 under here. And I'm going to look over here before I combine these any common denominators. What am I missing here that I have here? A 3x plus 1. And a 3x plus 1 on the top. Okay, so now that I have common denominators, I can do I'm gonna move this 2 in front of here because it's a lot easier for me to distribute when that 2 is in front. So let's go ahead and distribute that 2. And then subtract the 9 and put it all over 3x plus 1 since I have a common denominator. Okay, so I've got 6x minus 7 plus 2 minus 9 over 3x plus 1. So is there anything I can do? Some people may try to cancel 6 and 3. You can't because this is 1 unit. You can't just take little bits and pieces here. It's kind of like saying that I've got 27 and 37, and because I have a 7 here and here, I can cancel it, and it's really 2 and 3. Okay, it's the same idea. I can't just grab a number out of this group here and just cancel willy-nilly whatever I want. So that's why we're done with our problem once we hit this point here. It can't be solved anymore. So there we go, 5.4 in one easy lesson.